All right, guys, so we're going to look some more at these graphing rational functions, taking a look at them and figuring out all the rules for them. So in the first part here, it's talking about how a rational function just means we've got f of x equals p of x over q of x. Q of x can't be 0. If q of x is 0, then we're going to get what's called a vertical asymptote. P of x and q of x are polynomials. So to find intercepts, you should know the x-intercept, all we do is we replace the y, or the f of x, with 0. And then another way of thinking of that is just set that numerator equal to 0 and solve for x. To find the y-intercepts, we're going to replace the x's with 0 and solve for y. Guidelines for asymptotes. An asymptote of a graph is a line to which the graph gets closer and closer. We have three types of asymptotes. Vertical asymptotes we've talked about, horizontal we talked about briefly, and then slant is going to be a new type of asymptote. Vertical asymptotes are going to occur at each real zero of the denominator that is not a common zero with the numerator. There may be more than one vertical asymptote. A graph will never cross a vertical asymptote. If there is a common factor for p of x and q of x, the graph will have a hole, known as a removable discontinuity, at the point that makes the common factor equal 0. The common factor will not result in a vertical asymptote. All right, let me show you an example of this. So let's say our function, we've already factored it. Let's say it's like 3 times x plus 2 over x plus 2, x minus 2. See how we have a common factor right here of x plus 2? What that means then is that these two would cancel out. This does not give us a vertical asymptote. Instead, we would have a hole at x equals negative 2. And negative 2, the reason for that is that's what's going to make that 0. To find out the y value, where that hole is going to be, I plug negative 2 back into what's left over. So I would have 3 on the top, negative 2 minus 2 is negative 4, so I'd have negative 3/4. That's where the hole in the graph is going to be. Then we're going to have just one vertical asymptote at x equals 2. Now, we're also going to learn this rule down here about horizontal asymptotes. So I'm going to come back to this problem here in a minute. The graph of a rational function most of the time is going to have one horizontal asymptote. It might also have none, or it might have a slant. A graph can cross its horizontal asymptote. To check for this, set the function equal to the horizontal asymptote value. We'll do that here in a minute. If the degree of p of x, meaning the top, is less than the degree of q of x, meaning the bottom, then the line y equals 0 is a horizontal asymptote. So looking back here, the degree here is 0 because we don't have an x. The degree here is 1. This degree is lower. That means we're going to have a horizontal asymptote at y equals 0. I take this simplified form, this 3 over x minus 2, and I say, can that ever equal 0? Think about it logically. 3 divided by something has to give us 0. No. Cross multiply, you get 0 equals 3. You can't even solve it. So this will not cross the horizontal asymptote. Now, I want you to take a look at this function. I'm going to go to alpha to get a fraction. And this original function was 3 parentheses x plus 2 over x plus 2, x minus 2. I just want you to see what this looks like. Okay, so it's graphing it, graphing it, graphing it. See how we only have one vertical asymptote, and that vertical asymptote is at x equals 2. We have a hole in the graph at negative 2. In fact, look when I look at the table. Can you see how at negative 2 it says error? Well, there's no vertical asymptote at negative 2. That's actually where that hole in the graph is. Watch, I can't really be having it equal to negative 2. The calculator says there's nothing there. But watch if I get really close to it, like negative 1.999. Look at the value. The value is negative 0.75, basically. Do you remember right here where we said the hole is at -2, -3/4? That's supporting that. There's a little hole in the graph right there when x equals -2. And that hole is right there at -3/4. Okay, so that's what we're looking at there. So we've got when the degree is less than the, of the numerator is less than the degree of the denominator, y equals 0. Got to remember that. If the degree of the numerator is equal to the degree of the denominator, then the line y equals a over c is a horizontal asymptote, where a is the leading coefficient of p of x and c is the leading coefficient of q of x. That'd be like this. Let's say we've got 3x plus 1 over 4x minus 5. As we talked about, same degrees, so that means my horizontal asymptote is y equals 3/4. This lead coefficient divided by that. If the degree of p of x is 1 greater than the degree of q of x, then the graph will have no horizontal asymptote, but will instead have a slant asymptote. Divide p of x by q of x to get the equation of that slant asymptote. A graph can cross slant asymptotes too. Let's see here. I want to have the degree of the numerator 1 more than the degree of the denominator. Let's say we have something like this. If I want to find the equation of that slant asymptote, I do x minus 1, and I'm going to divide it into x squared plus x plus 0, basically. So when I divide this, x squared divided by x is x times x is x squared, x times -1 is -1x. I'm going to subtract by changing the signs and add. 2x divided by x is 2. Okay, I can stop now. That's going to be my slant asymptote. So this would have a slant asymptote of y equals x plus 2. Okay, if I looked at it on the calculator, you'd be able to see that slant asymptote. Let me just show you what it looks like. Okay, so here's the way this function looks. See how it comes up like this? And what that means is that we've got this y equals x plus 2 is going to kind of come up right through this. It's going to be a boundary for us. See how it comes right up there? And it's a boundary for us. Now it can cross that, but it doesn't always. All right, so we're going to do this whole problem. So to graph this, first I'm going to see if I can factor the numerator. I can't. That's going to just have to stay as is. In the denominator, it's x minus 2x plus 1. Nothing can cancel, so there are not going to be any holes in the graph. Instead, I'm going to have vertical asymptotes at x equals 2 and x equals -1. So I'm going to put in x equals 2, put in x equals -1. Okay, I'm going to find intercepts. I'm going to find my x-intercept by setting this whole thing equal to 0. So then if I do that, this is 0, and I cross multiply, and I'm going to get 2x squared minus 1 equals 0. 2x squared equals 1. X squared is 1/2. Take the square root, and that's going to be plus or minus, square root of 1 is 1. That's going to be plus or minus radical 2 over 2, comma 0. Those are going to be my x-intercepts. Radical 2 is about 1.4 divided by 2 is about 0.7. So those are going to be my x-intercepts. Let's find the y-intercept. Plug in 0 for x. 0, 0, that's going to give me 1/2. All right, so just getting some idea there. Okay, if the function crosses its horizontal asymptote, okay, yep, horizontal asymptote is going to be at y equals 2. That's because we have the same degree. I divide those lead coefficients. So I'm going to see if this thing can ever equal 2. So I cross multiply. 2x squared minus 1 would have to equal 2x squared minus 2x minus 4. These cancel out. I'm going to get negative 2x equals 3. So yes, it does cross. What's it going to be? Negative 3 halves. So at negative 3 halves, it's going to cross that asymptote. So there's negative 1, negative 1.5. Okay, it's going to cross right there. All right, now, if I want to do a nice graph of this, I need to check some points. Now, I know it's only going to cross right here. It's not going to cross again. So I'm pretty sure it's going to go down like this, but I'm just going to check. I'll check negative 1, negative 2, negative 3. Plug in negative 3. Negative 3 squared is 9 times 2 is 18 minus 1 is 17. Negative 3 squared is 9. 9 plus 6 is 15 minus 2 is 13. So that's about 1. And negative 3. A little over 1. Okay, so it's going to look like that. All right. Now, it's still kind of hard to see what's going on here. Is it coming back up? We're going to use our calculator just to help us on this one, just to make it sure we're doing this correctly. I don't need that anymore. Okay. Now, I would have to test a bunch of points to get this graph, but basically what's happening here is I would have to test something really close to this to see what's going on, but it's coming down like this, and it crosses that horizontal asymptote, and then it comes back up from the bottom and approaches it. Now, you're not going to be able to use that graphing calculator, but that's okay, because you can still get some pretty good values without doing that, just by hand. I just want to check my negative 3. Negatives, yeah, I just did the bottom wrong, 17/10. Okay, which made it 1.7, not down quite as far, it's a little bit further up there. Okay, so just be careful with that. Now over here I can see what's going on. It's going down like this and it's going down like that. Then when I check down here, all I really have to do is check one point because I know it's not going to cross this. So if I check 3, be careful, 3 squared is 9 times 2 is 18 minus 1 is 17. Plugging in 3 here, 3 squared is 9, 9 minus 3 is 6, minus 2 is 4. So that's like 4 point something. So that's going to be way up here. And I know it can't cross again, so it's going to have to look something like this. And again, we're not going for perfect graphs here. We're just trying to have the basic behavior of the graph. Okay, make sure I got everything. This is the important thing right here. That says x equals negative 1. All right, let's do one more. Okay, same kind of thing, factor. Okay, graph, vertical asymptotes, whole shebang. So vertical asymptotes here are going to be at negative 2 and positive 2. Nothing's going to cancel. Okay, so I'm going to find my intercepts. Let's do horizontal asymptote. Degrees higher on bottom, that's going to be y equals 0. Okay, so now I'm going to have to find my x-intercept. Just set the numerator equal to 0. What's going to make it equal 0? Negative 3. My y-intercept, plug in 0 for x. That's going to give me 0, 0, negative 3/4. It's good to get some points. All right, I'm not going to go to the graphing calculator on this one like I did on the last one. Just trying to do the other one kind of quickly. Okay, so I'm going to check a value of negative 3. That's going to tell me a lot. The only place that this would ever equal 0, equal its horizontal asymptote, is at, sorry, that's not right, is at -3, 0. That's the only place where it crosses. So I don't have to worry about, down here at crossing, it's not going to cross. Get rid of that point. So -3, 0, I already knew was a point. Now the question is it going to come up? Is it going to come up like that, or is it going to go like that? So to test that, I could check something like -2.5, but I can also check over here and see what's going on there. So if I check like -4, that's going to give me -1 over 16 minus 4 is 12, -1/12. So it's going to be just down there. So I know then that it crosses only here, so it can't come up and cross and come back down and get that point. It's going to have to go like this, because it only crosses that one time. All right, now I'm going to check -1. -1 plus 3 is 2. -1 squared is 1, minus 4 is -3. Check +1, 1 plus 3 is 4, 1 minus 4 is -3. And again, I know it doesn't cross anywhere else, so this is going to have to go kind of like this. Again, we're not going for a completely accurate graph. Check one more point, 3. All I care about, I know it doesn't cross down here, only here. So if it's a negative value, it looks like that. If it's a positive value, it looks like that. Plug in 3. I get 6. 3 squared is 9, minus 4 is 5. It's positive, so it's going to have to look like that. Okay, so when you take your quiz, you're not going to use a graphing calculator. You can use one of the ones that's not graphing. But I can use it to check, and you're welcome to use it to check. It's really kind of good to check it, just to get a feel for the way these graphs look, and then you kind of tend to see some consistencies with them and some things that they all have in common. All right, so here's that one. See that little part there? There's that little part. Yeah, that's pretty good, right? Okay, see how right here, that's where it's crossing? Let me show you this. I'm going to trace. So all a horizontal asymptote is it means that it's going to get closer and closer to 0. Like if I sat here and could just hold this out to infinity as x goes to -infinity, this number is going to get closer and closer to 0. It crosses that one time at -3, and then it just gets closer. All right?